So this is the next question. It is asked in the ISRO 2017 examination from the networks. Okay, so this is 2017 exam. ISRO. So what is the power loss in the 10 ohm resistor? What is the power loss in the 10 ohm resistor? How can we find the power loss in the 10 ohm resistor? So we have to find the current in the 10 ohm resistor. We have to find the current in the 10 ohm resistor. Then only you can find the power. Okay, if you can find the current in the 10 ohm resistor, it is easily can be found. So power is equals to I square R. Okay, so this is the thing. So how can we simplify this kind of question? See, here is one voltage source is given and one star network is given here. See, one star network is given here. So whenever if you find, see, these two are not at all parallel. Observe this. These two are not at all parallel. These two are not at all parallel. You cannot write the star to delta conversion here because there is a voltage source here. So you can only convert this delta network into star network. This is a delta network into star network. So that's why you can convert this into star network. Okay, you should not disturb this. Wherever you want to find the response, you should not disturb this 10 ohm resistor. Okay, it must not be included in the conversion. Any kind of conversion, you must not include. Okay, so that means if you include in any conversion, suppose if I take any, suppose after simplifying this, if I disturb this 10 ohm resistor, then there you cannot find the response in that. Okay, you have to keep that 10 ohm resistor as it is. Okay, so the point here is do not disturb the element in which the response is calculated, to be calculated, in which the response is to be calculated. So by keeping that 10 ohm resistor like that, you have to find the response. Okay, so you can convert this into star to delta conversion. Whenever you find this is one delta network, you have to convert into star. Let us suppose this is R1, it is R2, it is R3. Okay, R1, R2, R3. Now I have to remove this and I have to substitute this R1, R2, R3. You know how to find the star to delta and delta to star. Suppose one star to delta network is there. Suppose one star network is there here. Okay, let us suppose one star network is there. One delta network is there here. I want to convert this into star. Let us suppose this is R1, R2, RC, RA, RB, RC. Okay. Now I want to convert this into a star network. It is a delta network. I want to convert this into star network. Let us suppose this is R1, R2, R3. Okay, R1, R2, R3. This is RA, RC and RB. Okay, to find this R1, you know very well, to find this R1 is equals to the multiplication of these two, RA, RB divided by RA plus RB plus RC. RA plus RB plus RC. Similarly, to find R2 is equals to RA into RC divided by RA plus RB plus RC. So R3 is equals to, R3 means this one, the multiplication of these two, RB RC divided by RA plus RB plus RC. Okay, To find the R1, R2, R3 here, how can you find the R1, R2, R3? Here it is given that, let us suppose if you take this, what is the R1 here? Here R1 is equals to, the multiplication of these two, it is 15, okay, 15 divided by R1 plus R2 plus R3, 3 plus 5 plus 2, it is 10, okay, 10, this will be 1.5 ohms, right? What is R2? R2 is equals to this one. It is R2. 3 into 2 divided by 10. 3 into 2. What is 3 into 2? It is 6 divided by 10. R1, RA plus RB plus RC. So this will be how much? It will be 0.6 ohm. Right? Suppose what is R3? R3 is equals to this one. So 2 into 5. It is 10. 10 divided by 10. This will be 1 ohm. Right? So this is the network. So you can convert this into R1 is equals to 1.5, R2 is equals to 0.6, R3 is equals to 1 ohm. So the above network can be represented as, now observe this. This is the 10 ohm resistor. Now this is, observe this. So this can be, I am writing this 8 ohm because I can remove this now. I can remove this star network now. I can remove this delta network. Right? I can remove this delta network. Okay? So only I got this. So now I have converted the delta network into the star network. What is this value? This value is 1.5. This value is 0.6. This value is 1 ohm. Right? So this is the 10 ohm resistor. Now it is 8 ohm resistor. Now it is connected in series with R1. Okay, what is R1? It is 1.5 ohm, and next it is connected to R3. R3 how much? It is 1 ohm, and this 10 ohm and this R3 is connected. This 10 ohm and R3 is connected. Right? Now between this R1 and R3, R2 is there. Between this R1 and R3, R2 is there. And it is connected to 15 ohm source to the negative terminal. This is a negative terminal of the 15 volt source. Now this 0.6 is connected to this. Now this is the thing. Right? So this is the 10 ohm resistor. So you have to find the current in this. Right or not? You have to find the current in this. You have to find the current in this. You have to find the current in this. See, let us suppose this is I. This I is flowing up to here. This I is flowing up to here, and it is divided in this way and in this way. Right? The I amount of current is coming like this. Right? Now what you have to do? If you observe this, it is how much? It is 10 ohm. It is 1 ohm. How much it is? 11 ohm. Right? I am rewriting the above circuit again. This is how much? It is 11 ohm. Okay? It is 11 ohm. But this 11 ohm is parallel connection of 8 ohm and 1.5 ohm. I am rewriting the above equation like this. It is 15 volt source. It is a 15 volt source. This 15 volt source is connected to, how much it is? It is 9.5 ohm. 9.5 ohm, right? Then 15 volt source is connected to 9.5 ohm. Observe this. And again, right, this 10 volts, this 10 volts and 1 ohm. See, observe this. This is 10 ohm and 1 ohm are connected. It is 10 ohm and 1 ohm are connected in parallel. Observe this. This is 10 ohm and 1 ohm are connected in parallel to this. So this is how much? It is 11 ohm. It is how much? 9.5 ohm. These two are in parallel connection now. Okay. Now what is this? This 15 volt source is connected to 0.6 ohm, and it is connected to the junction of these two. And it is connected to the junction of this branch and this branch. right? It is 0.6 now. See, I am writing the 0.6 here. It is 0.6 ohm, right or not? So now it is plus minus, it is 15 volts. It is 15 volts. Now you have to find the current in this. How can you find the current in this? Okay. So voltage is there, resistance is there. What will be the effective resistance? The effective resistance will be, how much it will be? See, it is a current I. You have to find the current in that. Okay. Let us suppose, what will be the current? To find the current, I have to find the total current. I have to find the total current in this. What is the total current? Total current can be is equals to the voltage divided by the equivalent resistance. What is the resistance experienced by this circuit? What is the total resistance? What is the total resistance? So IT is equals to the total voltage divided by the R equivalent. What is R equivalent? What is R equivalent? R equivalent is equals to, if you remove this, R equivalent is equals to what? It is, these two are in parallel. These two are in parallel. It is in series with 0.6 ohm. Okay. So I can write R equivalent is equals to, what is this? These two parallel combination is in series with, see, observe this. The parallel combination of these two will be in series with this. Okay. What is the R equivalent? I can also write this 0.6 ohm here. Okay. I can also write this 0.6 ohms here. No problem. Okay. So now this is R equivalent is equals to 0.6 plus 9.5 in parallel with 11. 9.5 in parallel with 11. So it will be is equals to, R equivalent is equals to, it is 0.6 plus 9.5 into 11 divided by 20.5. Okay. It is 20.5. So if you simplify this and put it in this, so this will be equals to, this will be equals to how much? It is 9.5 into 11 divided by 20.5 plus 0.6. It is 5.6. So this is the answer here is, it is 5.6 ohms. It is the 5.6 ohms. So now how much it will be? IT is equals to, it is 15 divided by 5.6. So 15 divided by, it is equals to 2.632 amperes. It is 2.632 amperes. So this is the total current. So this is the total current. How much you are getting? It is 2.632. Now what will be the current I? The current I is equals to, the total current into opposite resistance by the total resistance. Use the current division principle. The current in this branch is equals to, IT. It is 2.632 into opposite resistance divided by the total resistance. What is opposite resistance? It is 9.5 divided by the total resistance is 20.5. Total resistance is 20.5. Here the current you got, you will get the current here, you will get 1.218 amperes. Here is the current in this branch. How much you got? 1.218. Here it is 1.218. This is the current. Now what you have to find? I have to find the power dissipated by this 10 ohm resistor. Now suppose if you want to find the power in the 10 ohm resistor is equals to I square into the current in the 10 ohm resistor, okay, into 10 ohm, right? So this will be 1.218 whole square into 10, 1.218 whole square into 10. The answer is 14.8. The answer here you got is, it is the 14.835 watts. Okay, it is the 14.835 watts. What is the answer here? Answer in the options has given that 15.31, 15.13. It is given like this. Options are 15.31, answer B 15.13 watts. Option C, it is 12.3 and 13.2. It is 12.3, answer D is 13.2 watts. So these are the options given like this. See, but we got the answer 14.835. We got the answer 14.835. So what will be the correct answer? The correct answer will be, so nearer to this, it is 14.8. Okay, actually he should not give the answers like that. Okay, so in the 2018 and 19 question papers, there are some 2018 and 2017 question papers, there are the answers not matching what we are getting the actual answers. Okay, so actually you should not give these kind of options there. He has to check once, but here the thing is, we can't do anything, right? So this is the correct option for this. Okay, thank you. So here is the question. Here the question is, observe this. The question is, the circuit is given, find the effective resistance faced by the voltage source. Find the effective resistance faced by the voltage source. Options are given. The options are 3 ohm, option B 4 ohm, option C 12 ohm, option D 16 ohm. Okay, so these are the options given: 4 ohm, 3 ohm, 12 ohm, 16 ohm. So this is the circuit given. So what we have to find? The effective resistance faced by the voltage source. It is given in ISRO 2015. So here we will solve some important gate questions and also ISRO questions also, because the standard is same. So here we will solve some previous gate questions and as well as the ISRO questions. Okay, so that your concept must be improved. Okay, so here we have to find the effective resistance faced by the voltage source. Here R value is not given. Observe that. Here R value is not given. If the R value is given, it can be easy to find. Okay, now also it is easy. See, the total current coming out of this voltage source is I amperes. Okay, in that I amperes, I by 4 is traveling in this, flowing in this resistor. If it is I by 4, now what will be this current? This current will be 3I by 4, right? 3I by 4. Now, how can we write? So I is equals to 3I by 4 plus I by 4. But what is this 3I by 4? What is the voltage? What is the voltage across this terminal? What is the voltage across this terminal? Observe this. If you clearly observe this, it is looking like what? It is looking like one voltage source is connected across this combination. It is looking like one voltage source is connected across this combination. Right? It is plus V. Okay? I amount of current is coming like this. Here I amount of current is coming. Here it is R. It is given that I by 4. It is how much? It is 4 ohms given. it is 3i by 4. Right or not? So now I am making a ground here. Okay, you can also mark the ground here. Okay, you can take any point as the reference. Okay, see, this is the redrawn circuit. Now what will be the voltage here? The voltage here is V only. The same amount of voltage is applied across the two elements, two branches. So if it is V, the voltage across this element is V, this is also V, right? So how can I write? So I can write I is equals to, so V is equals to how much? So V is equals to, so from this V is equals to 3i by 4 into, what is this? It is 4. V is equals to I into R, 3i by 4 into 4. And from this, what is this V? V is equals to, and the same voltage is also appeared here, I by 4 into R. I by 4 into R. So from this, these two are equal. If these two are equal, 3i by 4 into 4 means 3i only. Okay, 3i by 4 means it is 3i only. It is equal to, it is equals to I by 4 into R. So from this, what is R? R is equals to, it is 12 ohm. R is equals to 12 ohm. What are the options? The options given as 3, 4, 12 ohm, 16 ohm. Okay, you have to be careful here. You have to be careful here, because 12 ohms, see, 12 ohms are there in the option. 12 ohms are there in the option. So if you didn't read the question carefully, so you may go for that option only. So you have to observe that. What he has asked, we have to find the effective resistance faced by the voltage source. That means we have to find the effective resistance, means R equivalent resistance faced by this voltage source. What is the equivalent resistance? That means what is the effective resistance? So R equivalent or R effective is equals to, what is this? It is a 4 ohm parallel with, how much it is? It is 12 ohms. 4 ohms parallel with 12 ohms. So this is equals to 4 into 12 divided by 4 plus 12. It is 16. It is 3. It is 4. So answer is 3 ohms. The answer is 3 ohms. Okay, it is asked in the ISRO 2015. Okay, it is asked in ISRO 2015. Right? So you have to carefully observe the question. Okay, in 2018 there are some lengthy questions are there, but good questions. Okay, if it is lengthy, it will be for everyone it will be lengthy. Okay, so don't bother about that. You consistently prepare. Okay, so this is our next question. So one network is given consisting of all our batteries. He asked to find us the E. Find the E value. Find E. Find the value of E. So how can you find the value of E? So it is a very good question and very conceptual question. So that how much this question will really show you how much you are capable of the basics. Okay, how much you are comfortable with the KVL and KCL. Okay, it's a perfect KVL KCL application. Okay, KVL application. Okay, if you observe this, see here a 10 volts battery is given here. It is 0 volts. It is V2. It is V1. It is E. These all are 4 volts batteries are 4 volts, 2 volts, 1 volts, 5 volts batteries are given. So we have to find the E value. So how can we find the E value? How can we find E value? Okay. So for this purpose, so whenever only the batteries, only the voltage sources are given, we should think that. So you have to go for the KVL. Okay. You should go for the KVL. So it is better to use the KVL. Okay. So first of all we have to think about the KVL, and after that KCL, and after that we should go for the any theorems. Okay, and after that some kind of network reduction techniques. Okay, so in this we should go for the KVL here. So how can you write the KVL? You know, you want this, why I should go for KVL? Why I should go for KVL? Because the algebraic sum of the voltages is equals to 0. Within a loop, the algebraic sum of the voltages is equals to 0. So that's why I should go for the KVL. If I sum up all the voltages, it will be 0, and if I equate the entire sum equals to 0, then I will get the required one. So for that, which one I have to take? Which loop I have to take for the simplification, for applying KVL. Okay, so whenever the circuit is given like this, so not only this circuit, whenever if you find the terminals here, V2, V1, there are the floating, they are looking like floating. So here, what is the meaning of this? It is having a V2 voltage, with respect to the ground, This terminal has a V2 voltage with respect to ground. So that's why you have to mark one ground here. Okay, you have to mark one ground here. You have to mark one ground here, or here. With respect to ground means with respect to 0 volts, it is having V2. It is 0 only, so no problem. So what is this? With respect to ground, it has 0 volts. With respect to ground, it has 10 volts, right? So with respect to ground, it has V1 volts. So wherever you find, see, in any question, whenever you find this kind of floating terminals, you better to mark a ground. So that is a good practice, okay, which will give you a correct answer for you. Okay, so that's why otherwise you may face some problem. Okay, so this is the first thing you have to do in any question. Suppose if anywhere if the floating terminal is there, so you have to write one ground mark over there. Now which loop? See, is there any loop is observed here? Is there any loop? There is no loop actually, but observe the voltage. If you start from ground and you come to the ground, that will become one loop. Okay, if the current is started from ground and if the current going like this and reaching the ground means one loop. Or see, the current may start from here and ended up at here, or otherwise the current may start from here and end at here. So it is 0 volts means these two are at the same point. So that's why this one will become one loop. If I observe, if I take this one as the current direction, I can also take this one as the current direction, no problem. Okay, I can take this one as the current direction or this one also current direction. I am taking this one as one current direction. Okay, see, most of the people will think that what is a loop means it should start from wherever the current starts, it should come there only. Here also doing the same thing, but you should identify that it is 0 volts, it is 0 volts. It is 0 volts and 0 volts. That means it is completely it is making one loop. Okay, the current is traveling in a loop only. Okay, so this is the thing. Now let us suppose take the current is coming like this and ended here, right? The current is started from here and ended here. You can also assume this loop, right? Let us suppose the current is started from here, means this one means from this. Okay, let us suppose the current is started from here and end up here. This is one loop. Observe the loops. Okay, let us suppose the current is started from here and ended at here. This is 1, 2, 3, 4 loops are there. Okay, 4 loops are existing here, right or not? So that means it is started from 0 and ended at 0. It is one loop. It is started from 0 and ended at 0. It is started from 0 and ended at 0. Okay, so there are the 4 loops you can identify. Okay, 4 loops you can identify. So what we have to find? We have to find the electric field, the battery E. Okay, I'm going to EMT. Okay, so this is E. E means what? It is a battery. E means it is a battery. E means battery. So you have to find this battery. So what will be to find that battery value? Which loop I have to take? I cannot take this loop. I cannot take this loop because in this loop I will not get any E value here. I cannot take this loop. I can take this loop or I can take this loop because in this loop and in this loop the E is existing. Okay, which one to take? Which one will give you a simple answer? Suppose if I take this, I am writing this loop. Let us suppose the current is flowing in this direction. I assume, right? Okay. Let us suppose the current is flowing in this direction. So that's if you observe this, see, now I am taking this loop. To find E. Okay. How can I write the voltage KVL equation? See, it is just like what? It is a positive terminal with respect to this negative terminal. Okay, it is having a positive terminal. That means what? It is this point is having V2 with respect to 0 means I am taking this one as positive terminal. It is a negative terminal. Okay, it is a positive terminal with respect to negative terminal. Okay, it is a positive terminal with respect to the ground is a negative terminal, like that. Okay, so I can assume one battery like this, but which is having one positive terminal, next one is negative terminal. Right? So from this you can write the KVL. So how can I write the KVL? It is if the current is coming from here. Okay. So if the current is coming from here, what is this? First of all, it is 0. Right? 0. Right? 0. And first of all, it is starting at where? Minus. Right? You have to take plus. Plus V2. Plus V2. It is minus 2. It is minus E, it is minus 4, it is minus V1 is equals to 0. Right or not? Okay. See, the current is starting from where? It is 0. So whenever there is a minus terminal is meeting first, you have to take this minus as plus. Plus V2. Plus V2. Next one is what? There is a positive terminal coming first. The positive terminal is coming first means what? We have to take minus here, minus 2 volts. The positive terminal is coming first. You have to take minus E first and the positive terminal is coming first. You have to take minus 4 and the positive terminal is coming first. So you have to take minus E1. So this is the first equation. So what is this equation? So V2 minus E minus 6 minus V1 is equals to 0. This is the first equation. So from this, is it possible to find E? No, not possible to find E. So it is not a valid, it is not useful KVL here. So which one I have to take? I can take this loop, okay, to find E. So if it is 0, it is 0. What is this? It is minus 1 volt. Minus 1 volt and next one is what? Minus E and next one is minus 5. Next one is minus 5. Next one is, if it is minus 5, what is this? It is minus 10 is equals to 0. All are having a positives. So whenever the current is touching the positive terminal, you have to take all the values negative in the KVL. Okay, or otherwise you can also exactly follow the opposite manner also. Okay, anyhow you have to follow a one notation. Don't follow two notations, either this one or that one. So from this, what is E? So E is equals to minus 16 volts. E is equals to minus 16 volts. Observe this, within a simple 1 KVL we got this. So you have to identify which one we have to take, which loop I have to take, either this loop or this loop or this loop or this loop. Okay, so like this you can identify. Suppose if I want to apply, observe this, suppose if I see in this case what I have taken, I have taken this as the current reference. Suppose if I take this one as the current reference, what can I write? So here, let us suppose the current is flowing in this direction. Okay, the current is starting from this ground to and ended at the ground. Okay, so what happens here? The current is coming like this, right? The current is coming like this. So negative terminal is meeting the current. Okay, so that's why I have to take a positive 10 volts, right? Or first of all, what? It is 0 plus it is 10 volts. It is how much? Plus 5 volts plus E plus 1 is equals to 0. This is a KVL. So from this, what is E? E is equals to, this is 10. It is also again minus 16 volts. So you can go for this. Understand or not? So what is the meaning of this? The meaning of these terminals are, see, the meaning of these terminals like this means, see, observe this. It is just like one battery. Okay, with respect to ground. Okay, how much it is? It is minus, it is plus, it is V2. Right? What is the meaning of this? The meaning of this one is, it is a 10 volts battery. It is just like, it is minus, it is plus, it is 10 volts. Right? What is the meaning of this? I can remove this V1, enter setup here. So it is just like this. That means it is having a voltage with respect to, it is having a voltage V2 with respect to ground. It is having a voltage 10 volts with respect to ground. It is having a voltage, how much? It is V1 with respect to ground. That is the meaning of this. Understand or not? It is a 0 volts, it is a 0 volts, it is a 0 volts and 0 volts. Anyhow, it is ground. So that means what? 0, that's why what? 0 minus, first of all, if the current is coming like this means what? 0 plus V1 plus 4 volts, like this, plus 4 volts plus E plus 2 volts minus V2. Okay, so this is the meaning of the exact question. Okay, now, so we got E2, E value. Now suppose if you want to find V1, V2 values, how can you find? Suppose if you want to find V1, V2, how can you find? So in the given question, suppose if you want to find the V1 and V2, how can you find V1 and V2? So can you take this loop? No, because 2 are there. You can find, see, already we found, you can also put there, but there is one more equation, the V1, V2 are there, so you cannot find the V1 and V2 separately, right? So which one you have to take? You can take, observe this one, because only V2 is presenting in this. So suppose if you write the see, come to this loop, write the KVL in this loop. If you write the KVL in this loop, what is this? It is 0 plus V2, 0 because the current is coming in this. Okay, 0. First of all, what it is coming? Minus sign is there. So write plus V2. Next is what? Minus 2 volts is there. If the minus 2 volts is there, you have to take, sorry, this is plus 2 volts is there. You have to take 2 volts. Now what is this? Minus 1 volt is there. So you have to take plus 1 is equals to plus 0 is equals to 0, right? So from this, what is V2? V2 is equals to, it is minus, V2 is equals to 1 volt. V2 is equals to 1 volt, right? V2 minus 1 is equals to 1 volt. We got it. Now, how can you find V1? How can you find V1? So you have to choose this loop. You have to choose this loop or this loop. You can go this way or this way, no problem. Suppose if you go from this way, what happens? It is 0, it is 0, because the current is coming in this direction, right? It is 0. First of all, what is meeting this point, meeting the current? Negative terminal. So you have to take plus 10 volts, plus 10 volts. So negative terminal is meeting. So that's why you have to take 5 volts. Next, positive terminal of the battery is meeting. So you have to take 4 volts, minus 4 volts. So here, positive terminal of the V1 is meeting. So you have to take minus V1 is equals to 0. Understand? Minus V1 is equals to 0. So from this, what is V1? So V1 is equals to, it is 15 minus 4. 15 minus 4. 15 minus 4 is 11. Okay? 11 volts. Right? So we got these answers. We got these answers. Right or not? So like this, you have to solve this question. See, you can also use this loop. Suppose if you use this loop, what it will be? Let us suppose the current is going in this way. Let us suppose the current is going in this way. What I have to write? It is 0. It is 0 plus V1 plus 4 minus 5 minus 10 is equals to 0. Right? So V1 is equals to, it is what? Minus 1 minus 10. It is equals to 11 volts. It is equals to 11 volts. Okay? You can also go this way. You can also go this way for this to find V2. Suppose if you go this way, what happens? It is 0 minus 1 plus 2 minus V2 is equals to 0. Okay? So from this, what is V2? V2 is equals to 1 volt. Okay? You can go this way or this way. Okay? It is same. Okay? So depending on the current reference, you always follow one notation only. Don't follow two notations. See, there is one more convention. Okay, some people what they will take? They take, whenever there is a negative is there, they will take minus V2 only. If they will take minus V2 and they will take plus 2 volts and they will take plus E and they will take plus 4 volts. Next they will take plus V1 volts. Okay, if the plus is touching the current, first they will take the positive value only. Okay, either you can take that way or this way. Now I am following this way, so it is the best way to use. It is the best way to use. So that's why you follow this. Okay, so whenever there are the terminals, the floating terminals are given in the question, okay, you have to mark the batteries like this. There is no confusion in that. Okay, so whenever you find the V2 like this, you have to mark the batteries like this. So definitely you will not get any problem. You will not get any problem. You just simply write the KVL. You just simply write the KVL. Okay, I hope you got it. Okay, thank you. So these kind of questions will be asked in the GATE examination and as well as the ISRO examination. Okay.